Okay, for multiplying binomials. Again, still having that image in your head that we're going to have the coefficient. You're going to have the index. And then you're going to have the radicand. Okay, multiplying other than the indexes happen to be the same. And I can't think of a problem with anything that's in the homework where they would be different. Question mine? Okay, so first, and again, I can't think of a problem where the indexes are different, so this part should pretty much be given. Second thing is, once that's good, you're going to multiply the coefficients. And then you're going to multiply the radicand. Okay, and once you've done that, then the fourth thing is, you're going to simplify. Now, and with the simplify, you're going to have a couple of things you're going to have to do. Number one is you're going to have to break down the radicals. Because your radicand, more than likely, the radicands are going to be bigger. Because you're multiplying, the radicands are going to be bigger. So you're going to have to go back and break those down. And then the other thing you're going to do is they're going to make you use what we did in the first part here. You're either going to add or subtract like terms. So they're going to make you use the first part that we just got finished doing with the first part of the section to make you do that same thing with the second part when we start doing the multiplying binomials. Now, and if we're doing multiplying binomials, that means we're going to be doing the full method. So we're going to do the full method, but now we're going to have radicals in that one. So we're going to be doing the full method with square roots and cube roots and third roots and fourth roots and that kind of thing. Mostly it's going to be cube roots and square roots for the most part. All right, here we go. Let's give you some examples. Let's go with 3 plus 2 squared root of 5. And then 2 plus 4 squared root of 5. Okay. And again, this one should pretty much be a given. I don't think they'll make it where the indexes are different. So now you're going to multiply your coefficients. So we're going to do 3 times 2. And then 3 times 4 squared root of 5. So 3 times 2 is 6. 3 times 4 is 12. Squared root of 5. Okay, so there's the first and the F and the O. Now we're going to do the I and the L. So now we're going to do 2 times 4 for 8. Sorry, 2 times 2 for 4. Square root of 5. And then we're going to do 2 times 4 for 8. And then we'll make sure you do 5 times 5 to make that 25. Okay, and almost every single time when you do this, there'll be a couple of times where, depending on the numbers, it may not be able to do this. But pretty much every single time, you should have some things that you can add and subtract with like terms. You're also going to have some things you're going to have to break down. The 6 is good because it's a whole number, nothing you can do there. But this one is just like we've got finished doing. You've got 12 squared root of 5 plus 4 squared root of 5. Since those are the same radicals, with the radicands being square root of 5, we can do 12 plus 4 and make that 16 square root of 5. And then on the end, we did square root of 5 times square root of 5 to get 25, but the square root of 25 is just 5. So we've multiplied the coefficients, we've multiplied the radicands, we've got those 4 terms, we've added and subtracted, we've broken this one down, so this is a 6. Nothing you can do with a 16 square root of 5. Do 8 times 5 and make it 40. And you can add the 40 plus the 6 and make that 46 plus 16 squared root of 5. And which one you put first over here, it doesn't matter. If you put the 16 squared root of 5 first and the 46 behind it, either way is fine. Doesn't matter which one you do. Okay, and we're just going to do a couple more just to make sure that we've seen a couple of different, all the different cases you can see when you're going through these. But it's basically just going to be that you're doing the full method. The only difference is instead of it just being x's and y's, now you've got square roots to kind of go through and work through these. Okay, so let's give you one where we've got square roots everywhere. Let's go 5 squared root of 2 minus 4 squared root of 3. 6 squared root of 2 plus 7 squared root of 3. Okay, and for this one again, it's just doing the full method. So first thing is, we have 5 times 6 for 30. You've got square root of 2 times square root of 2, make that square root of 4. 5 times 7 for 35. Square root of 2 times square root of 3 will be square root of 6. And then finish it up, we've got to do the 4 square root of 3 times both of these. Now, and don't forget that is negative with that 4, so it's negative 4 times 6 for a negative 24. 3 times 2 for 6. Negative 4 times 7 for a negative 28. And then 3 times 3, 4, square root of 9. Okay, and when you're doing the binomials, every single time with this one, you should have 4 terms when you go through these. First times first, first time outsides together, inside times inside, last times last, and just go back and do that. And again, you're gonna have stuff you have to break down. There's no if, ands, or buts about this one. You've got square root of 4 for this part. Well, square root of 4 is 2. You have 35 square root of 6 and 24 square root of 6. Those two terms, you can add those together, or in this case subtract it. It's 35 minus 24. Well, that's 11 square root of 6. Minus 28, and when you do the square root of 9, that's 3. Question? Okay, 30 times 2 is 60. Can answer that one easy, right? 11 square root of 6, 28 times 3, that is an 84. And now you got the 60 and the minus 84, so do 60 minus 84. That's a negative 24 plus 11 square root of 6. And again, it doesn't matter which one you put first. If you put the 11 square root of 6 first, you just need to put the negative or the minus 24 behind it. So either one of those two answers would be okay. Okay, we're going to do one more full method going through the steps on this one, and that one's going to walk us right into, it's not really division. I mean, it is, but it's not. It's what we did yesterday on the back end of it where we were doing the rationalizing part. This one's going to be the same thing. We're going to rationalize it, but it's kind of sort of like division, but not exactly. Okay, for the last one on the multiplication, we're going to do 6 minus the square root of 12 and then 6 plus the square root of 12. And again, it's just doing the full method, so we've got 6 times 6, 6 times 12, we've got the square root of 12 times 6, and then square root of 12 times 12. Alright, 6 times 6 is 36. 6 times square root of 12 is just 6 square root of 12. Negative square root of 12 times 6 is going to be negative 6 square root of 12. And then negative 12 times positive 12, that's a negative 12 times 12 is 144. Alright, 36 is 36. Nothing you can do there. You've got the plus 6, minus 6. And again, they're both square root of 12, so we're going to add or subtract the numbers in front. 6 minus 6 is 0. And what happens if you do 0 times anything? It's 0, right? So that's 36 plus nothing, which would just be 36. And again, if we had positive times negative, I guess technically that's negative, but if you do 36 minus 0, that's still just 36. On the last part, you've got the negative square root of 144. Well, if you do the square root of 144, that's just a 12. So the middle two terms become 0, which basically knocks each other out. So basically we've got the first term minus the last term. 36 minus 12 is 24. So when we change the signs, that's a conjugate. And that's going to walk us right into the next thing we're going to do. Because every single time if you multiply a number of times its conjugate, the middle two terms always knock each other out. So we're left with just the first times the first and then the last times the last. So we don't have to worry about doing that middle part. We're just going to do 6 times 6 and then the square root of 12 times square root of 12. And that's basically what we're going to do for the last thing here. We're going to ask you to rationalize the denominator. And we rationalized yesterday. But yesterday it was just one term in the denominator. Today it's binomial, so that means you're going to have 2 terms in the denominator. And if you do don't remember yesterday, if we had something like, it could have been 1 over the square root of 5. If we asked you to rationalize the denominator yesterday, all you had to do was multiply the top and bottom by whatever you had in the denominator. So this one would have been square root of 5 on top. Bottom part would have been square root of 25. Again, if you'll make that a 7, just so it's something other than 1, we'll put it there. Square root of 25 on the bottom would just be 5. And that was the rationalizing we did yesterday. That it was just a single term denominator where you had just a number. And all you had to do was multiply by the same square root on the top and bottom. And that way the bottom came out to be this perfect number without a square root on it. Okay, for what we're going to do today, it's going to look different because it's going to have to be a 2-term denominator. So we're going to do something like this, where we're going to do the 2 square root of 7, and that's going to be over square root of 3 minus the square root of 5. Okay, and we're going to do this one just like we did up here, that you're going to multiply by the conjugate of the denominator. So when we were multiplying by conjugates way back when, they were kind of building us up to get to this point that is, as long as we can remember, and again, if you don't remember exactly that it was conjugate, hopefully now you go, oh yeah, we just changed the sign. That's the big thing they want you to remember is that to do the conjugate, we just have to change the sign. So we're going to take this 2 square root of 7. It's over the square root of 3 minus the square root of 5. Now all we're going to do is we're going to change it, so now it's going to be a plus. So it will look like that. Now the one thing you probably want to do when you do these is, because we are multiplying by those 2 terms that's there, I would say put parentheses around every single thing that you have here. Okay, on the top part, that one is really just distributive property. It's not even full method. So we're going to do 2 square root of 7 times square root of 3. That's going to be 2 square root of 21. we've got a plus 2 square root of 7 times square root of 5. That's going to be a 2 square root of 35. Okay, and on the bottom one, we're just going to put it this way. We're going to do the conjugate shortcut. And the conjugate shortcut says all we're going to do is we're going to do the first times the first. So we're going to do square root of 3 times square root of 3 and make it square root of 9. And then you're going to do the other one, square root of 5 times square root of 5. Now, it is a negative times a positive, so it's going to be a minus. 5 times 5 is 25. And you don't have to worry about the middle two terms, because when you do the conjugates, they're going to knock each other out, and you're going to be just left with the first times the first and then the last times the last. And it'll always be the same number times itself and then the same number times itself every single time. Okay, now top part, there's really not much you can do in the top part. You could take the 21 and break it down as 3 times 7, but that won't go any farther. 35, you could break it down, make it 5 times 7, but that won't go any farther. So the top part is pretty much done. The bottom part, though, we got a lot to it. Square root of 9 is 3. Square root of 25 is 5. So if we do 3 minus 5, that's a negative 2. Okay, now, here's where we have to kind of go way back to some problems that we did before. If you get to the end and you've got just a number on the bottom, they want you to split this up as 2 separate fractions to see if there's anything you can do to simplify this one. So this one, we're going to break it up as 2 times the square root of 21 over negative 2 plus 2 times the square root of 35 over negative 2. So if you have just one number, and you'll have just one number with these, you've got to take that and put it underneath both of the fractions you've got on, or both of the terms you've got on the top. And if it was 2 over negative 2, that would just be negative 1. So that's a negative 1. Now in this case we don't need the 1 because we've got the square root of 21. So that's the negative square root of 21. Same thing here. These two 2's will cancel. We're going to have a negative and then square root of 35. Alright, let's do one more of those. And that'll be the last thing we'll do. Alright, so for this one, let's give you kind of a, went through the homework, found about the hardest one you could get. We'll make sure we do that one. So let's go 4 square root of 5 plus square root of 10. That's going to be over 8 square root of 5 minus square root of 10. Okay, so the very first thing is, on the bottom we had 8 square root of 5 minus square root of 10. So now we're going to do 8 square root of 5 plus square root of 10. And whatever we do at the bottom, we're going to do the same thing on the top. Okay, and just to make sure we don't miss anything, I would say go back and put parentheses around every single part of the fraction that you've got here. Okay, in the top part, we're going to do it in red just so it kind of stands out. The bottom part, we're going to do it in blue just so we can kind of see the difference of the two we're looking at. Okay, so the top part, you're going to do, and again, this one, because you've got 2 terms and 2 terms, it's all just the full method here. So it's 4 times 8 for 32, 5 times 5 for 25, And then we're going to do 4 times 1, basically, so 4. And then 5 times 10 for 50. Okay, then we're going to do the same thing with the 10. This time it's square root of 10 times 8 square root of 5, so it's basically 1 times 8 for 8. 5 times 10 for 50. And then square root of 10 times square root of 10 would be square root of 100. Yeah, so with this one, because you had to do the full method, there wasn't really a shortcut, just had those 4 numbers, and we'll come back and break those down in a second. Okay, on the bottom part, when we do this one in blue, we're going to do the conjugate shortcut. And every single one of these we're going to ask you to rationalize, you're going to do that same shortcut. So we're just going to do the first times the first. Now, here's where you have to be a little bit careful. That it's still 8 times 8, so that is 64. And then 5 times 5 is 25. So we're still going to do 8 times 8, 5 times 5. Then we're going to do the 10 times 10. It's going to be minus 10 times 10 for 100. And you'll always get to do that, and somebody's going to say, well, will we do that every time? And if it asks you to rationalize, yes, you get to do that conjugate shortcut every single time when you go through these. Okay, so on top, you got a bunch of stuff to clean up here. Square root of 25. Well, that's 5. You've got 4 square root of 50 plus 8 square root of 50. You can add those two terms together and make it 12 square root of 50. And at the end, you've got square root of 100. Well, that's just a plain 10. On the bottom, square root of 25 is 5. Square root of 100 is 10. So for that, that's what, 320 minus 10? And on the top, 32 times 5 is 160. We've got a 12 square root of 50, and then a plus 10. And again, not all the problems are this long. We picked this one because it's the longest one out here. Bottom part, 320 minus 10, that's 310. Top part, you've got 160 plus 10, that's 170. And you've still got the 12 square root of 50 hanging out behind it there. Okay, we need to separate these two into 2 separate fractions because we've got the one number on the bottom. But there is one little bit more we've got to do. Because can you take square root of 50 and break it down? You can, right? Because you can make that. Now, we can do 5 times 10, but couldn't you also do 25 times 2? So that makes that one 5 square root of 2. So we've got the 170 plus the 12. We're going to take that square root of 50 and replace it with 5 square root of 2. That's over 310. So for that one, we're going to do 12 times 5 and make it 60. Square root of 2, and because the 310's on the bottom, that's where we're going to break it up into 2 parts. So it's 310 here, and then 310 here. Okay, and the good thing with this one is, the easy part of the simplifying is they all end in 0, so we can just basically go back and knock these 2 zeros out and make it 17 over 31. Knock out these 2 zeros and make it 6 over 31, and that square root of 2 is on the top. Okay, so a whole lot of simplifying later. Finally get the answer. And again, there shouldn't be that many. I think there's one in the homework that's that long. Most of the other ones should go a little bit faster.